Well, hello everybody. Oh, good evening, depending on where you are in the world watching this. I'm Robert Massey, and I'm the Deputy Director of the Royal Astronomical Society, and it's my pleasure to be here for this webinar this evening, for this live streaming event, I should say. Webinar makes it sound very, very corporate indeed. That's not what we're about. I'm going to be here tonight, joined by Alexandra Loske, who is over in Dusseldorf in Germany. She normally lives actually very near me in my hometown in Lewes in Sussex, which is where I am tonight. Sam, in the background, I should say, we've got, various members of RAS staff, Sam, Jessica, and Lucinda helping run this show. And we're also joined quite excitingly by Agapios Elia from the Troodos Observatory in Cyprus and 1010 Astronomy out there. He's doing a fantastic job. But the great thing is that as an observing event, the nice thing is he's in a part of the world where the sky is really, really clear. Unlike, I have to say, the bit of the UK that I'm in right now anyway. Now, you might ask why we're doing this. Hopefully you saw some of that from our website and the various details, but this is a National Astronomy Week event from the 1st to the 9th of this year, 2025, is National Astronomy Week. It varies immensely whenever it runs because it commemorates or celebrates an event in the sky. And this one is about chasing the moon. It's tracking the moon as it goes from being a crescent, as it was, well, it's still a crescent, but a thin crescent as it was a couple of days ago over in the sky by Venus, Neptune, and Saturn. And it's moving across night by night over the course of the slightly quirky 9-day long week that is National Astronomy Week. And by the end, it'll be over by Mars. So what we're going to do this evening is start off with a couple of us, Alexandra and myself. She's an art historian, and she works at the Royal Pavilion in Brighton, talking about the kind of the moon in science, art, and culture. It refers actually to a book that we put together a few years ago to commemorate the 50th anniversary of the Apollo 11 landings. So, we're very much looking forward to sharing that with you. And then after that, we'll have Agapios actually showing us live images of the moon and hopefully a couple of planets as well, and maybe even some other targets too. We do really encourage you to ask questions as well. Just put them in the YouTube chat, and we'll be able, we'll pick those up as we can. So do that, absolutely. And if you've got any questions about what we're seeing through the telescope, anything we're saying, then go right ahead and ask, or indeed on any other matter related to astronomy. We're quite open to that. So that's absolutely not a problem. Now, I think the next thing I would like to do is to bring in Agapios, actually, just because he has taken the trouble to join us from Cyprus. Of course, they're 2 hours ahead of us, so it's later in the evening for him. So we really appreciate him giving up his time to do that. And actually traveling up into the mountains, I know he can tell us all about that now. So are you there, Agapios?
Hi everybody, can you see me and hear me?
We can, definitely.
Excellent. So, Kalispera από την Κύπρο. Good evening from Cyprus. Thank you so much for having us. And yeah, here I am at the newly opened Troodos Observatory. Very, very happy to be here finally and getting to have the opportunity to share the wonderful night sky here in Cyprus with all of you. Well, the sky is absolutely brilliant right now. As I was driving up, there was a bit of a fog, a bit of a scare there, but everything is just fine here. And I am actually looking at the moon through the telescope, getting ready. As I said, it's a beautiful, brilliant night. And yeah, really looking forward to sharing the live image of the moon and the planets later on through our incredible telescope here. It's a 0.5 meter telescope, 20 inch, and really, really looking forward to share views with you.
Great stuff. And I think you're quite high up, is that right?
Yeah, exactly right. I'm at 1,250 meters above sea level. That's 4,500 feet, which is exactly what you need when you want to do high quality astronomy. Because let's be honest, the higher you go, the less atmosphere you have to contend with. And up here on the Troodos Mountains, the atmosphere is just clear, spectacular, and the night sky is indeed beautiful. And take it as an open invitation to everyone looking and watching tonight. Uh, do consider coming down to Cyprus to enjoy the beautiful night skies that we have here.
I think that's an invitation many of us would like to take up there, actually. Yeah, but it's certainly enthusiastically. So if I ever get the chance, I'm definitely up for it. So with that, I think I'm going to bring in my co-author of this book, actually, that we referred to, or I referred to earlier on, Dr. Alexandra Loske. Alexandra is over in Dusseldorf right now, and I can see her video switched on, which is a good sign, and she's unmuted. So,
Oh,
Alexandra, do you want to take us into that cultural aspect of the moon to begin with, and then I'll come in after you.
oh, am I going before you?
You can, or we can do. I don't really mind, but do you want to go in with some poetry? Let's set the mood for the
Oh
evening.
my God. I hope that's the right thing to start with. I'm very happy to do that. So I'm just going to share this. And I was going to say hello, Lewis, and hello from Düsseldorf, but also hello to the universe. It's great to be. Um, so, as Robert mentioned, we wrote a book together a few years ago. I think about in 2017. Was that right? I had this idea for a book that looks at the moon, like we are doing today. But so that brings together the science, the astronomy, and the art. Because I'm an art historian, so I know very little about astronomy. But I was very keen on the moon for various reasons. So we wrote this book, and sometimes looking at the same image, so unpicking it from our perspectives. And there we are in the Royal Astronomical Library with the book. And I've since stayed in touch with the moon. I'm not done with the moon yet, so I've contributed to this rather amazing book here on the right, which has just come out, called Lunar, by Thames and Hudson, edited by Matthew Schindel. And I'd contributed two short pieces on the moon in literature and popular science books. But what I'm going to talk about today, just to get us in the mood, is poetry. And when our book came out in 2019, I thought, I've done so much work on the moon, spent so much time with Robert, and we were giving lots of lectures. I want to hear what other people have to say. So I wanted to know what poets, people who can really write, uh, say about the moon. And I brought out a little anthology called Pale Fire, New Writing on the Moon. Any writing on the moon after the Apollo 11 moon landing. And why is this interesting? Well, I think it's always good to hear someone else's perspective. And just to give you an example, here is one of my heroes, Jorge Luis Borges, Argentinian writer, who lived through that age of getting to the moon and what happened afterwards. So just look at what he says before we get there in 1964, saying, "I secretly assumed, as poets do, the duty on me to define a moon." So is it a particular um, poetic topic? Well, of course it is, of course. And then just after we got there, he writes these lines: "Two men walked on the moon, others will later. What are words to do, and what of the dreams and fashionings of art before this real, almost unreal event?" And I think that's I mean, I was too young to remember this, and so was Robert. But it must have been so enormous a human achievement that maybe even good poets found it hard to describe that in words. And then a few years later, he reflects on this huge event, the Apollo missions, and says there is so much loneliness in that gold of the moon. The moon of every night is not the moon that the first Adam saw. The centuries of human wakefulness have left it brimming with ancient tears. Look at it. It is your mirror. And I think this is definitely a theme that runs through our relationship with the moon, that we think it's a reflection of ourselves and of the earth, perhaps, and that we also keep looking at it, reflecting on who we are. So I was told 4 slides, I'm cheating a bit. So just to remind ourselves that, yes, we have, since we have records or any evidence of human activity and creativity, we know that we have had a very special relationship with the moon for all the right reasons, of course. It is so tantalizingly close, yet so far away. And here we have one of the earliest surviving pieces of poetry, fragments composed by Sappho in the 6th century BC. And, she says something like, this is, of course, in translation: "Moon has set, and Pleiades, middle night, the hour goes by, alone I die. So she's clearly here sort of contemplating the human conditions, but crucially, she does so by looking at the moon or the night sky. And apparently, we can date this poem just by how she speaks about the Pleiades and the moon setting and so on. So it is something that us humans love doing and maybe have to do, reflect on the moon and reflect sort of with the moon. And we're making huge leaps here, but of course, this is why I initially got interested in the moon, because my particular period is the Romantic period in architecture and painting, but also in literature. And we see this huge surge in, the moon as metaphor, as symbol, as an anchor in poetry. And we're not even considering the novelists who also pick up on this, the prose writers. And there are many, many examples. Some of these romantics also combine it with imagery, such as the great visionary poet William Blake. And I'm just showing you a few examples here where he really comments on our obsession with the moon and our sort of, huge ambitions of trying to get that. And why would we do that? Why would we want to conquer the moon? And he does so with images and words. But he also links the moon to our ancient history, to our human history, here on the right, framing it. I think this is from Jerusalem, his work Jerusalem. He frames the moon with Stonehenge, and you all know why he does that, of course. But to stick with the romantics, there's really no time to pick many, but I'm just, Coleridge writes about the moon or uses the moon as a huge, big motif in, for example, the Rime of the Ancient Mariner. But here's John Keats in 1819. So, and I like that because it was 200 years later after he wrote this, we actually got to the moon. So 200, that was the 50th anniversary when our book came out. But Keats in 1819, at the height of Romanticism, writes a very, very long poem, which I'm not going to read to you, called The Eve of St. Agnes. St. Agnes is the patron saint of virgins, and it's basically an ancient Roman story, and it is a woman, St. Agnes, who stands in the moonlight. And I'm not going to bore you with this, but it's rather wonderful how John Keats bathes this woman. And of course, the moon was very often, or still is, associated with womanhood and women and virgins, of course, and the Virgin Mary. He bathes her in the light of the moon with his lines, and uses a lot of sort of color descriptions. And then at the end, she herself becomes quite moon-like, and still she slept an azure-lidded sleep in blanched linen like the moon. So it's rather wonderful, in lavendered sleep. And just to illustrate this, you see John Everett Millet's Eve of St. Agnes painting from the high Victorian age, where so he's illustrating the poem, but I found it really interesting visually that he bathes this woman in green light. It's very rare. Some artists do that, but depicting moonlight as green is quite rare. But the poem is full of colors, which is another subject matter, really. So what I'd like to finish with what is, and you might argue with me, but this is one of the best known poems, which is actually about the moon. But of course, much more than that, because good poetry should be. And I think it's absolutely wonderful. It captures all of this that I've been trying to sort of pack into these few minutes, that poetry is just one expression of our deeply, deeply intense relationship with the moon, and how the moon becomes a reflection of the human condition. So we look at it and we think about ourselves. And it's so succinct, it's so short, it's wonderful. This is Ted Hughes' poem Full Moon and Little Frida. And just for context, so we are just before the moon landings. We are in the 1960s. It was published in 1967, but he writes it in 1963. So there's a lot of talk about getting to the moon. And he has a young daughter, Frida, And she herself is now a poet, actually. And they go out and they look at the moon, or they just go out and look at the sky. And I've done that with my child. And I was amazed at that moment. And I'm sure most parents, or people who, know young children have experienced that a child suddenly realizes there's the moon and we have some kind of connection to it. So here is little Frida, just a few years old, going out with her father, and she suddenly has this conversation with the moon. So it's about an atmosphere. It's about how the moon creates an atmosphere and suddenly makes us think about our position really in the universe. Even if we don't know exactly what it is, we realize we're part of a much, much bigger thing. So here it is, a cool evening, a bit like today, really. A cool evening, drunk to a dog bark and the clank of a bucket, and you listening, a spider's web tense for the dew's touch, a pail lifted, still and brimming, mirror to tempt a first star into a tremor. Cows are going home in the lane there, looping the hedges with their warm wreaths of breath, a dark river of blood, many boulders, balancing unspilled milk. Moon, you suddenly cry, moon, moon. And this is exactly what my daughter did, and I'm sure Anna did that too, Robert. And then the moon suddenly becomes this anthropomorphized creature that we all relate to. The moon has stepped back like an artist, gazing amazed at a work that points at him, amazed. So I hope that got us into the mood. Thank you so much for listening.
Yeah, I really appreciate that. And Ada, by the way, for anybody listening, is my daughter, who's now 15 and probably not quite as idealistic about her expressions about these things as back then, and I'm sure that was true for Flora as well.
Yeah, but do you remember that moment when she spotted that? Oh my God, there is something that might have something to do with that.
I think it's also, I think, and we'll come to this, right? Because I also think, when we come to Agapios in a bit, it's the same reaction people have when they actually look through a telescope at the moon, even adults, because most people have never done it. And they suddenly say, there's really nice YouTube footage of somebody doing this on the streets of LA, setting up a telescope, and passes by and they just bounce back with shock. It's fantastic because they've never seen it. So it's remarkable.
Yeah, of course. I mean, you're going to talk about the telescope, aren't you? But we once did it at an event, didn't we? We brought a telescope, somebody brought a telescope, so we did our spiel, and then we set it up and made people look through. And yes, and that's a realization. Here's maybe a piece of us, and it looks back at us as well.
Right, I'm going to share my slides briefly, take us through it if I get the right bit. We've done last year. I should mention, by the way, I don't have another slide for National Astronomy Week, but it's in my background. But if you go to the website, you'll find there are about 250 events around the UK. So do check those out. Chances are, if you're in the UK, at least there's one near you. I know there are some more online. They're in science centres, observatories. A lot of amateur astronomy societies involved, because that's very much the backbone of this week, all those kind of volunteers that do these things. And that's what I think is actually really great about it. It's a really fantastic celebration. However, I won't dwell on that now. I will come back to it. I'm going to talk very briefly about how the kind of things that we've learnt from, or the way that the invention of the telescope, and then the second big change in our understanding in the universe, space exploration, has transformed our ideas. So if I had time, and I don't, I could talk about all the Neolithic stuff, all the very ancient depictions. You can look that up on a different occasion. But what I would start by saying is our view of that thing in the sky, where it's the only object in the night sky where you can really see any detail with the eye. Everything else is point sources, constellations are collections of point sources of stars. But the moon, you look up and you see its shape changing. You can see some splodgy figures at least, and obviously various cultures then imagined those into their mythologies. It becomes important in that sense. But the real transformation obviously was the invention of the telescope in around 1608, first used by Thomas Harriot in West London with some crude imagery, and then at least artistically better imagery by Galileo a few months later. And these are the kind of things he was able to draw, which, by the way, are absolutely remarkable. To see this with the kind of telescope he was using, which was not great. It's the kind of thing that would be comparable maybe to something you'd get in a Christmas cracker, I think, you know, nothing special at all. But he was able, along with others in that period, very, very rapidly to start expanding our ideas. And of course, what they discovered was that the moon, rather than being, you know, it was always seen as somehow on the balance between perfection and not, because you could see these features, but looking at it in detail, it became obvious there were mountains and craters and ridges and, you know, and all these things that were just invisible from the Earth. And it became clear that it was another world rather than, you know, anything else, that it was actually a kind of place you could imagine going to and walking around. And that, I think, for me, is the transformation that the telescope brought. And of course, it's also the closest celestial object to the Earth as well. On the right, this is just a sort of flippant inclusion of a French print here showing an imagined 18th century astronomer. You know, I'm not sure any of them really quite look like that, unless it looks like it's somewhere in Provence or somewhere. So maybe the weather was good enough to dress like that at night, but, you know, slightly mocking them in the way they're looking at it there. And you can see the moon's got a smile on it, a face on it, which is a very common feature. But for the kind of serious science, very quickly people tried to map it, and they realized there was an enormous amount of detail. This is one of the earliest really good scientific maps from the late 17th century by Cassini, who was an astronomer working at the Paris Observatory, originally Italian, but moved to Paris. And you can see, actually working with Louis XIV, as I recall, and you can see the amazing detail. So look at that. This is a telescope from 350 years ago, roughly. And it still shows extraordinary detail. All those craters, the kind of things we'll see later on, these ridges, all these splashes, which we now know to be associated with big impacts. So lots of argument about what craters were, how they were formed right into the 20th century. But, you know, we now know they're almost all caused by asteroids or meteorites hitting the surface. But you can see that splash around them. Again, you know, no understanding what those was at the time. And there are a couple of really charming features. We have a copy of this map in our collection in the Royal Astronomical Society in London, and we bring it out for various public events from time to time. So if you'd ever like to see it, then do sign up for one of those. Keep an eye on our website, on our social media feeds, and you can see those. But if you look at the very bottom down there, you'll see there's a little feature. I'm not sure whether people are seeing my mouse. That's an interesting question. But if you are, I'm circling it. And in any case, it doesn't matter too much. On the right is a zoom in, and it looks like a woman's head with tresses of hair. Now, that's, you know, when I saw that, and when I saw that on that map, and this is from me having been an astronomer at that point, but, you know, 25 years at least working in the field in some capacity, I didn't believe it. I saw it and I thought, oh, come on, this is just Cassini having fun. He's commemorating some, you know, the woman in his life of some kind. But it turns out that actually, if you look through a telescope under the right lighting conditions, that's exactly what it does look like. And I saw it for myself through a telescope, and that's my picture of it down there, you know, if anybody doesn't believe me. So sometimes it's that effect that we see in other objects in the sky. We do see ourselves, our brains are so wired to look for familiar features. Now, if I just go forward a slide, there we go. So skipping forward 300 years, if you wonder why it's so hard to get there and why we haven't been back in 50 years, one of the simple explanations is that it's a long way. So the image on the left here is the Earth, and then on the right is the moon to scale. Very often in children's books you see, and many adult books, you see the moon and the Earth quite jammed together, and the planets as well, by the way. There's really big distances between them, but actually to scale, that's how far they are. You could fit, I think, about 36 Earths between the Earth and the moon. So, you know, it's not like going to Australia. It's not like, you know, slowly exploring the Earth, where you've got the advantages too, obviously, of being able to usually eat and have water and air at the very least. In space, you don't have any of those things unless you bring them with you. So, you know, it never entirely surprises me it took so long to get there. And actually, also, I think it was remarkable that we did it so early after the space age began, just 12 years after the Russians launched Sputnik. People were walking on the surface of the moon. Quite extraordinary rate of progress. Two or three things that to draw your attention to here. One is this on the right is the view of the moon we're familiar with, the full moon. Okay, you know, I suspect everybody's seen a picture like that with the big splash patterns of the craters there again. These big dark regions, they're lava plains. They were called seas because they're sort of reminiscent of that. But on the left is the far side of the moon, and it's the same world, but until the space age, we didn't have good pictures or any pictures of the far side at all, because it's never visible from the Earth. It's always because the way the moon moves around the Earth, we just don't see it. And that was entirely different. And that's always, it looks like an entirely different planet. Or an entirely different world. It's always a shocker to me just how different it is. But now, of course, in the space age, we have, it's easy enough to have missions going around and sending pictures back to the Earth. This is the view, of course, that the astronauts that went to the moon in the Apollo program would have seen some of this, albeit they were much closer than that. I will go forward past that because it's a repetition of that. So, 50 years ago, 60 years ago, we saw those political commitments by the Russians, the Soviet Union, and the Americans to send people to the moon. The Russians did, the Soviets, I should say, the Soviet Union doing it very, very quietly. They had a sort of program. If they'd got there first, obviously they would have made a huge noise about it. At the time, they didn't like to talk about anything that didn't work. And in contrast, in the United States, President Kennedy making speeches to Congress and this one famously at Rice University there to commit the Americans to going to the moon by the end of the decade, specifically men. It was a very that kind of era. They built the Saturn V rocket you can see in the middle. Only the very, very top bit there actually got to the moon, and an even tinier bit returned, a tiny triangle. That's the mission patch for the Apollo mission. It was made a bit less, it was actually made a bit less aggressive, I'm told. They put these laurel wreath in because the symbol of an eagle was seen as a bit too aggressive. So it was kind of made to say, well, it was about peace. It was about going there with peaceful intentions. There's one of the pictures on the previous mission just before that where they didn't land Apollo 8, but they went around the moon and took for the first time a picture of the Earth and moon together. No one had done that. In fact, there were very, very few images of the whole Earth at all. It turned out to be quite hard to do. And then there is Buzz Aldrin walking on the surface of the moon, who were, one of the first two people to do that, along with obviously Neil Armstrong. And then lower down is one of the later missions where an astronaut is looking at a giant rock, because it was about collecting rock samples critically and then understanding its origin, and thereby also how the Earth formed as well. And then finally, I'm going to finish up by speculating. It's still, I think, likely that we'll see people back on the moon in the near future. As in the next couple of years. There's the Artemis program in the US designed to do that. Exactly which launch vehicle does it may be a different matter. But I had the huge privilege, along with the artist Luke Jerram, of talking to the Artemis 2 crew who are going there, I guess, 2026 perhaps. We were just talking to them actually in part about the work that Alexandra and myself had done about the influence of the moon in different cultures. And they are incredibly nice people and incredibly excited about it as well. It was the most phenomenal Zoom crew call to do a Zoom call with a bunch of astronauts that were going to the moon. Amazing, really nice people. Anyway, so you can see the kind of things there. The proposal is to have a space station called a Lunar Gateway in orbit around it, which would be a European-American project with other partners as well. And then on the right, is one of the visions. This is, I think, more of an architect's vision. I think this is Richard Rogers who designed it for the European Space Agency, this idea of a moon village. And you might think that's a place with a pub and a post office because, I'm British, that's the kind of way I imagine villages. It's not going to be like that. It's going to be a pretty tough environment on the whole, but it is nonetheless this sort of intention to build a scientific base so that people would be living there for long periods, at least, doing the science. I'm not sure we'd make it a colony as such. That's going a long way, or actually having lots of people living there, but certainly some scientists. That's the aim. And in the near future, as I was saying, we should see people walking on the surface once again. So I'm going to stop there, I think. And at that point, I'm just scanning straight through stuff. That's an interesting question I'm seeing from my colleague in the chat. All the planets apparently can fit between the Earth and the Moon. Now, that's a really good question, actually. Is that true? I'm now thinking about it. It might be the case, actually, because even Jupiter and Saturn, although they're really big, now I'm going to have to go away and work this out, I think. But it's close to that. It does say that things are a lot more spaced out than you think. So I suggest, actually, we can go to Agapios, actually, if he's ready. Are you ready there, Agapios?
Yes, of course. Ready when you are.
Great. Okay. Do you want to bring in images of the sky? Take us through it. Tell us what you're seeing, and bring those on the screen. We'd love to see it. I can tell you, definitely sitting here in the UK, you may be wrapped up against the cold, but I'm pretty sure you didn't have a grey old day today, and that's all we've had. So it's a huge pleasure to bring you in.
Actually, it's summer every day here in Cyprus. Winter seems to have forgotten about us. So I'm hoping to be able to share the screen here and show you what I'm looking at. Is that coming through okay?
We're getting a screen sharing. It's not getting the picture yet, but we're getting it's saying that you're screen sharing. Give it a minute.
Okay, how's that?
Okay, now we can see what looks like your computer
Okay.
desktop. So your control system for your telescope.
Okay, so I'm just trying to get lined up on the moon. I was just a minute ago, just before I came in. There it is. Okay, just need to bring up the exposure. Okay.
Oh, wow, there we go. And there we
There
go.
we are. There we are. So that's a live view of the moon from the Troodos Observatory telescope, which you can see up there. So this is a 20-inch telescope that we have installed inside of our 6-meter dome on the top of the mountain here in Cyprus. And we are now streaming live images to you via a dedicated astronomy camera that we have plugged in the back of the telescope. Where you would have a regular eyepiece for people to look through, we've just swapped that with a dedicated astronomy camera running a specialized software to be able to stream images to the internet. And that's what you're looking at right now in this control environment. So the image is a little bit freezing. I think it has to do with the computer, but anyway, we can still talk about what we can see. Now, the major drawback of using large telescopes is that they have way too much magnification. So even in the lowest setting, it still looks like we're in a spaceship really close to the moon looking at the individual craters. And we are somewhere close to the area of crater Langrenus, if I'm pronouncing that correctly. But we are going to be able to just tour around and see some lunar highlights as soon as we can get this started. There we go. So I'm using a little joystick here, I hope you can see, to point the telescope left and right. I feel like an Apollo mission pilot, to be honest, looking out the window. And yeah, so the view is not the best it could be because the moon for us is actually really low in the sky right now. So we are looking through a lot of atmosphere. Whenever you look at things in the sky that are low, you actually tend to observe through a lot thicker column of air. And all of those individual air currents distort the view a lot. And they actually do produce the moon illusion that we all know. The moon always looks larger when it's closer to the horizon, and it looks a different color as it does when it's up high in the sky. It tends to go to a warmer tone, as does the sun. That's why we get those beautiful views of the sun when it's low in the sky. And you should never look at the sun, by the way. But the reason why that happens is because of the thick atmosphere that the light has to pass through. And if you look closely in the image, you can see the shimmering. It's almost as if we're looking through water. I hope that's coming through okay.
It's coming through really well. Yeah.
Excellent. Okay. So in astronomy, we call that the astronomical seeing. The seeing tonight, where I am, is, I would say, pretty average. It's not the best it could be, and it's definitely not the worst, because we can still see individual craters down to, let me see if I can measure one, and just to give some perspective. Let me go back to the crater Langrenus that we were talking about before. I'm just pointing the telescope. Now the telescope is on a computerized mounting system that has motors, and it's actually lined up to the North Celestial Pole, so it can track the moon. So if I let go of the controls, it will still follow the moon. So we're not going to lose it. But let's see if I can spot an interesting crater that we can measure. Let me see. Oops, there we are. Okay, so if you notice inside this crater over here, these dark silhouettes are actually mountain peaks. Now this crater, Langrenus, is, just pull up some information here, is 132 kilometers across. So that's almost half the diameter of my island. So quite large. So I would say we are looking at the smallest crater that we can see tonight is probably somewhere around the 5 to 10 kilometers in diameter. So just to get some perspective, the smallest patch that you can see on the moon is about 5 kilometers across with this telescope in this resolution. Let's just scan around. And well, obviously we can see the difference in the lunar soil. We can see the dark areas and the bright areas. We can see the lunar maria. These are areas where the soil is actually a result of volcanic activity. That's another interesting crater right there in the center. This is crater Messier, which is really spectacular. It has these long ejecta rays that you can see here. Let me just pull up the exposure a little bit. There we go. These really long rays here, really spectacular to see, and you can actually see this with a small amateur telescope. You don't need a really huge observatory telescope to see these craters. So we keep just touring the moon. Now here's another interesting formation, one of my favorites actually. This is a lunar rill, the straight wall. Can you see that?
We can, yeah, it's looking good.
Try and zoom in.
It's a little dark, Agapios, if you can increase
Yep.
the contrast, but it's
Yep.
I can see it between those two points there.
There we go.
Can you move the mouse to show where it is again?
It's right over
Perfect.
here. Right over
Yeah,
here.
got it. Yeah, so it's just about
I'm
lit up.
gonna try and clear up the image a little bit.
Yeah.
Show
I
you a
think
bit
what's
of a better
interesting,
view.
by the way, why you're doing that is that people assume that the moon is really bright because we get used to seeing it at night. And we look out and we think it's incredibly bright. But actually, if you look at it, the one trick you can use to look at it during the day against, say, something like a piece of rock on Earth lit up by the sun, and you realize how dark it is. And when the astronauts went there, you know, they described it as being like their driveways. You know, thinking about these tarmac, as we would say here, driveways, and that was the kind of color and contrast it has.
Yes, if I remember correctly, they called it magnificent desolation.
Desolation, exactly right. Yeah, exactly.
Yes.
Somebody on YouTube is asking if we can see Hadley Rill or Mount Hadley. That's a good question. I think that was the Apollo, one of the Apollo, as I recall, an Apollo 17 target, and it's a lovely feature. I can't remember where it is, so I'm going to depend on you for
I'm
this.
looking it up right now. Happy to point to it. I'm looking
Is
it
it
up
down
right
there
now.
at the bottom?
It's actually in the shaded part of the moon tonight.
Right.
So we should be able to see it in the following nights, maybe 2 nights from now.
Okay. One of the things to say to people watching as well is that, you know, as you watch the moon waxing or changing phase, so it starts off as a thing present and it appears to be, you see more of it each night. That's just an artifact of where it is compared with the position relative to the Earth and the sun. So from night to night, the lunar day, which is much longer than the day on Earth, you know, it's a month long effectively, means that we get to see things slowly. And moonrise or sunrise rather, and sunset on the moon is a lot slower than it is on Earth.
Yes,
But
exactly.
we've got
And I'm
other
just
features there,
pointing
haven't we?
now.
Like those volcanic splash patterns and things there. The wrinkle
I'm actually
ridges.
pointing at a very dramatic area of the moon now, where you can see a couple of really interesting features that I think are ideal for, say, a beginner who wants to get into observing the moon through a telescope. One is the difference in the shaded areas of the craters and how that changes night by night. So somebody can observe the same crater over a course of a few nights and see how the shadow progresses as the moon illumination changes. And it also gives you an idea of the depth of some of these craters, because obviously there's shallow craters and there's really deep craters. Some of them can be, I don't know, maybe a few kilometers in depth, which is tremendous if you consider the process by which they were formed. And of course, looking at this intricate pattern of the snaky, wavy deformation of the lunar soil here is just incredible. And we're just coming up now to one of my favorite craters. Just going to center it now for you. There we are. Let me just fix up the exposure a little bit. I really do hope that's coming through okay to you.
It is coming through pretty well, actually. Yeah, I'm just
okay.
I mean, it's fairly dark, but we can see it. I can see it at least pretty clearly. You mean the big one in the center that's slightly?
Yeah, the big one in the center.
Yeah, yeah.
Okay, so that is crater Posidonius. So that's a 95 kilometer crater, 95 kilometers in diameter. And if you notice, there's a fine structure, some really thin circular structures inside of that crater. Now this goes to show just how dynamic the view of the moon is. There's just so many details, hidden details hiding inside what may seem like a pretty straightforward feature. So anybody, even with a small telescope, can really train their observing skills and trying to eke out more and more detail on the moon. It's an incredible proving ground for a beginner observer.
I'm always struck by that. And I think also what's so nice about it is that because it's close to us, because it's, relatively big, even a pair of binoculars is enough to show you craters. And it's, which then means, I guess, when you think about people like Galileo and Thomas Harry using the simplest possible telescopes, a pair of binoculars is still better than those. And you won't see this sort of view, but you will see craters, you will see mountains. It becomes very obvious that it's a three-dimensional world.
In my opinion, the fact that even with as you say, even with a small telescope or a small monocular or anything that can magnify a little bit, you can detect things on the moon that you cannot see with your eye. That should be inspiring enough, and just incredible enough to make somebody just consider just what else is out there. And that's how I got started in astronomy, to be honest. I remember myself as a little kid, yeah, using a tiny toy telescope, and I could just barely, yeah.
Exactly. I think that, it's still a great target for the public to see, I was thinking, by the way, also with Posidonius, you said it's what, 60 kilometers across?
95.
Right? 95. So to put that in perspective, I'm going to give obviously a very local analogy because that's where I am. And that's roughly the distance from where I am down in Sussex to London. So these things, I think sometimes you look at them and you think, oh, that's quite big. And then you realize actually it's like having a crater covering a large chunk of the southeast of England. That's just the crater.
Exactly.
When these things hit, you imagine, I mean, I remember hearing about the rate at which they were hitting. So the really big craters, you were talking even during this period early in the solar system when there were lots of objects smashing into each other. You would have been talking about bigger events probably every 100 years or so, but which are still a lot. But the devastation, I mean, the drama of that, if that hit and it's that you see the crater, but it would have thrown debris across the whole of the lunar surface in a very, very violent event. And I imagine some of that would have, well, I'm not sure how much of an atmosphere the Earth would have had at the time, but it would have, it would have certainly arrived at the Earth, some of the debris as well. Somebody's asking online, Sidewalk Astronomy Netherlands. Hi, you're in the Netherlands. Fantastic you're joining us. Can we see the bridge between Promontorium Lavinium and Promontorium Olivium? That's a very specific request near Proclus. So
we'll do our best to accommodate that.
Sorry, go ahead.
We'll do our best to accommodate that. I'll just need to hear that one more time. But before that, I actually wanted to just highlight something really interesting. Another one of my favorite things to observe on the moon, and something that I think is quite spectacular, is catching the sunrise on the very, very edge of the illuminated side of the moon. I don't know if you can see that on the screen. Yeah. It's just tiny, tiny bright beads of light coming off the very, very fine tips of the moon, as we say. And that can be quite spectacular. It's almost as if they're coming out of the darkness, out of the void, to fulfill, you know, more and more of the beauty of the moon. It's just an incredible view.
When I see that, I imagine, you know, if you were a future astronaut just standing there watching the sunrise in
Exactly.
almost, you know, completely surrounded by darkness, and then you just catch these rays as it rises.
Can I hear that request again?
Yeah, Sidewalk Astronomy Netherlands. Can we see the bridge between Promontorium Lavinium and Promontorium Olivium near Proclus?
Okay, let's see if we can find that.
And I just want to let Agapios know that we lost your video feed from Troodos. You are sharing, but we can't see it.
I can see it. I can see it still. At least I can see the image of the moon, and I can see the observatory.
Shall I try and restart my feed?
I think you're well. I don't know. I can see it. I don't know if
I can see it too on the
Yeah.
other accounts. I can see it too. Can we
Okay,
confirm
good.
that?
It's okay. That's fine. It's just not showing up on Zoom, and that's okay. I do see it on YouTube. All good.
Yeah, I can see it on Zoom as well. So it might be a connection thing or something.
Okay. If somebody can just point us in the approximate direction of where that
Proclus.
feature is. Yep.
We should ask Sidewalk Astronomy Netherlands. Do you want
Yeah.
to put that into the chat in YouTube? I can't see that actually. I can see the Zoom chat, and then we'll give us more specific instructions. And
I think I got it.
great.
I think I got it. I'm just going to go to it.
On the edge of Mare Cressium.
Yep. Going there now.
Excellent. I have to say, I admire your familiarity with so many features. Actually, I know some, but this is impressive stuff. You'd be
Well,
a good
to be
lunar
honest, it's a skill that one acquires after a long time of doing this. I mean, it's a question that I get all the time from beginners. How do you know where everything is? And to be honest, it's just familiarity. And I often like to you know, associate it with, say, for example, that you just moved to a new apartment and you open your window for the first time. You may notice that, okay, there's a mountaintop, okay, there's a tree or a park there. But after spending years looking at the same view, night after night, day after day, you'll be able to spot things changing immediately, and you'll know exactly what you're looking at any given time. It's just a matter of familiarity.
That may be true, but it's still impressive. Can you? So did you have it on the? They said the Sidewalk Astronomy said they could see it. Benood, who I actually know, hello Benood, he's at the University of Sussex. I can see it on YouTube, so that people are still getting it, I think.
Okay, just pointing to the area now. There we go.
Oh, that's very nice. Yeah.
Honestly, it does feel like I'm piloting the Apollo.
It's absolutely beautiful. Really stunning imagery here. And I love the fact you can see. So one of the other things, and yeah, feel free to jump into, but you've got this big, smooth mare region there. So where a really large impact hit the moon, excavated a very large impact basin, you know, almost described somehow something bigger than a crater, that filled with lava from inside when there was more of that in the moon, smoothed it over. And then the younger craters go on top. And I remember this is the process of geological superposition, which sounds very impressive. It actually means that younger things tend to be on top of older things when you've got this sort of process happening in this case. So a younger crater is hitting older ones and excavating them. And that's also why you see craters within craters in other cases as well.
So we've got the crater that our friends in the Netherlands requested. That's the bright one in the center of the field of view, the one that's showing some ejecta rays. So that's the crater they wanted. So hopefully they can pick out the feature that they're interested in.
Yeah, it does look, I have to say, it does look remarkably bright compared with its surroundings there as well.
Yes, indeed. Well, I have to say the moon is really low for me. I mean, as you can see, the telescope is pointing nearly horizontal. So it really isn't the best observing conditions. I did get a peek at Jupiter before through the telescope before we came online, and because it's really high up, the view was just incredible. But I can say that it's actually quite a nice view. Surprisingly, a nice view.
I think it's really, really impressive, to be honest, despite, I mean, I can tell you low down is better than not being able to see anything at all. So we've got another request. Can you go? I don't know. Is it visible? It probably is visible. Someone's asking to see the Moon Maiden as well. Is that visible at the moment?
Can you repeat the request, please?
Can we see the Lady of the Moon, the Moon Maiden?
The Lady of the Moon.
Right. I will find, I'm sorry, it's terribly rude to use your phone when you're doing this, but I'm going to look up what the name of the feature is, the proper name.
Yes.
Promontorius, hang on. 2 seconds. It is Promontorium Heraclides, and it's a mountainous cape situated in Mare Imbrium.
Promontorium Heraclides.
Yes, that's it. Yeah, exactly.
In the shaded part.
Yeah, I wondered if it's in daylight or if it's on the night side.
No, it's in lunar nighttime right now.
You need to wait a couple of days, I think, don't we, or something? Yeah. So that's a shame. But again, actually, as I was showing with my sites earlier, it's another feature that's not that hard to see if you've got even a modest sight. I really like the Messier craters there, the 2 double craters you've got in the center, and I think there was weird speculation, like things like was this now I'm not sure how seriously that could even be considered, but older books, that Patrick Moore's classic Guide to the Moon had the idea, the speculating the idea that something, and I think it was ruled out, and actually that some meteorite had come in at a ridiculous angle and almost carved a tunnel through, and then clearly.
Yeah, it certainly does look like that. It's quite spectacular to see. Yeah, in a small telescope, it almost looks like a little comet on the moon.
Yeah, exactly. So just wondering if you got this shows I should really know. Can we see things like, is Copernicus visible yet?
Not yet, I think.
Or Aristarchus, maybe?
Yep, going to point to that now.
Brilliant. Excellent. You going to Aristarchus or Copernicus?
No, we're going to go to, we can see Atlas, Hercules. We can see Posidonius that we saw before.
Great.
We can see Theophilus again near the Terminator. And what else we can see?
I also think the other thing to understand as well, right, is that you don't have the same processes for creating mountains on the moon as you do on Earth. So what you're looking at, you don't have the plate tectonics, these large masses of the Earth's crust pushing against each other. What you have on the moon instead is this sort of scouring and battering that's, leaving mountain ranges, which are usually the rims of giant craters, and but some of them are incredibly high. I mean, I think they'd certainly be respectable sized mountains on Earth, and even though the moon's gravity is only a sixth of what it is on the Earth, it would still be, I think, a pretty serious challenge to climb them.
I do have another famous crater in the field of view there, Petavius, 184 kilometers across. It's actually one of the first recognizable craters as soon as the moon goes into the sort of a 2-day phase, but it's just a tiny thin crescent. It's one of the first craters that you can immediately pick out when it's shaded like that. Again, another very popular target for beginner moon gazers.
Do you, I wondered actually, Agapios, I think we should, in a minute, I'll bring Alexandra back and allow you to go and find Mars as well. There you go, Sidewalk Astronomy Netherlands. Now you can see Rupus Altai. There you go. These guys obviously know their features too. I was going to wonder could we look at near the south pole of the moon? And you probably know why I'm going to ask this, but I was just thinking about places people might go to if when astronauts return there.
Yep, going to point there now.
Okay.
Oh, there's another interesting trio of craters.
Yeah, that's standing
just
out.
Coming
there.
out of the shade there. A famous trio of craters. Theophilus Cyrillus and Katharina.
Look brilliant, don't they? And again, you know, these are things that modest telescopes show. They're not that hard to spot. They're really remarkable. I know that people spent. I've got a friend, Sally Russell, who describes herself as a sort of space artist, and she spent a lot of time. We had to use one of her pictures in our book actually, but she spent a lot of time just drawing single lunar features, and that was the kind of thing that astronomers before the invention of photography would do, because you had no other means of recording these features. So your artistic skills are really, really important. I think I would have struggled. I mean, there is a technique, but it would have been a challenge. So is that the South Pole?
Fasten your seatbelts. We have begun the descent to the lunar South Pole. If you look out your window, there it is.
So the reason I've asked Agapios to point at this is because this is a region of the moon that's a lot of interest to scientists and also to space agencies considering astronauts returning there. And the reason is that there are craters in the South Pole that are deep enough that they essentially don't get sunlight. Now, part of the reason for that is that there is a coincidence between the tilt of the moon's axis with respect to its orbit and the tilt of the orbit of the moon around the Earth. And the two combine in such a way that the moon is almost perpendicular to the sun. So it has very low it's different setup anyway, but it has very low what you would describe as seasons. So there are places, you know, the equator of the moon will, during the lunar day, you will have the sun overhead. But if you're at the poles, it will be very, very low down. It will circle the horizon. And so what that means is that there are places where maybe not absolutely complete darkness, but near to that. And so they're very cold. And early in the solar system, when there was more material moving around, and to a certain extent to this day, you have objects like asteroids and comets that crashed into the moon and the other planets as well. It was just that they more often have thick atmospheres and weather that wipes out the record of those craters. So craters on Earth, but nothing like the same number. And these asteroids and comets delivered water to these bodies. So we think that was to a certain extent how that happened on Earth. And on the moon, we know now, because of various space missions have detected it, there are deposits of ice at the South Pole of the moon in particular, and also actually throughout the surface to an extent. So if we want to build a base, one place might be to try and do it there, because we could use that water, not so much to do things like, you know, it's not so much about drinking, but you can make rocket fuel with it. You can break it down into hydrogen and oxygen and use it as a resource. So there's a lot of interest in going there. And also, if you're high up on a mountain there, you pretty much get permanent sunlight rather than none at all. So it's a good place to put things like solar power. So I notice we've got just a couple more minutes before we go to a different object, actually, at which point I'll bring Alexandra back in and also perhaps bring up another slide for a news item that people might have heard about today. Any final
I do need a few minutes
options?
to point the telescope.
Of course, yeah. We'll give you 10 minutes at least. Don't worry. You tell us when you're ready. But any final features on the moon that you'd like us to
There's
show
just
us?
so many.
I think what I
you know,
really
as
like,
I say, the moon is a spectacular target for people who are, you know, just beginning, you know, getting familiar with the night sky, and it can be so awe-inspiring. Just keep it simple. I mean, just follow the changing phase of the moon just with a simple pair of binoculars, and there's just so many things you can see. Not to mention whenever we get a phenomenon on the moon, like an eclipse, but just looking at the moon itself and how it changes. How its appearance changes night after night. It's just so incredible.
we've got another thing. I'm just looking at the chat here, a point made by one of my colleagues that there is, as part of National Astronomy Week, if you go to the website, which is astronomyweek.org.uk, you will find various resources there. One of which is a National Astronomy Week moon tracker. There we go. And there it is on the screen now. So that shows you where the moon will be each successive night. And, you know, you could, if you've got children or you're a child watching this, you can get this printed out and shade in, draw how the moon appears to you on the different nights. And you should see that phase changing over the night. And it'll move each night. It'll be over in the west to begin with, and then it'll move across over toward, when you talk about in the early evening, over towards the east as the 9 days progress. So we've got another 6 days to go. And there's a QR code to use it as well that you can download.
I'll take that as a cue to move the telescope to another object.
Yeah, you can do that. I think I'm going to see, I guess Alexandra is there as well still. So
I'm here.
hey, how are you doing? You're still connected, which is great. So
yeah,
it was nice for these things to have an international audience as well, and international speakers.
Well, I didn't give you the most famous German moon poem by Johann Wolfgang von Goethe, which is a song, or he called it a song called "To the Moon," "An den Mond." And that was a lot about love. Of course, there was no time to go into that today, but a lot of things happen under the light of the moon.
Yes.
Yes, it shines on murderers and burglars, but also on lovers and
exactly.
tricks. So that's that. But having seen these beautiful images and hearing you, astronomer, talk about what fascinates you or fascinated you in the first place about the moon, and it is, of course, the features. It is the pockmarked surface and why it looks like that. And this is something that writers, not just poets, but general writers on the moon, also picked up from very early on. So trying to understand what the surface of the moon is like. What is it? And I mentioned this idea of the moon being a mirror of light, but also mirror maybe of ourselves. And from very early on, when people are sort of not just observing but also envisaging the moon, what is that surface like, what is on there. So from about the 5th century BC, we have Orphic poets comparing or envisaging what is on the surface of the moon to being very, very similar to what we have on Earth. So, there is a world and it has many mountains, many cities, many mansions. This is from the 5th century BC. So in a way, we wanted to see ourselves on the moon, really. And Plutarch, I think, is the first writer who comes up with this idea in the 1st century of the moon having a face, or that there is a face that appears on the surface of the moon. And of course, that is not the case, but it is this wanting to see ourselves in the moon. But also, once we could see more, so once there was the most basic of telescopes in the early 17th century, and then better telescopes. Many of you will know this, but until then, certainly in the Western world and in Christianity and Christian sort of imagery and thinking, the moon was associated with the woman, or more specifically, the Virgin Mary. So, it's pure and it's passive, and it just reflects the great light of the sun, which was the male principle. And we see a lot of images of the Virgin Mary standing or sitting on the moon or in a sickle moon, and it's always perfect and white and pure and virginal. And once we were starting to know more about the moon, and that it is not perfect, it is pockmarked, and it has gone through a lot of violence, sort of impacts and all that. That was not, that really sort of stressed out, for want of a better word, Christianity. Because what do you do with that idea of it not being pure? So can it still stand in for the Virgin Mary? Can it still be a symbol of the Virgin Mary?
And tell me something else, actually, not necessarily in that context, but I was just thinking to myself, because from what I recall, you hadn't looked through a telescope at the moon or much until we did one of our earlier talks. So what was your response to that when you saw it?
It was everything I'd hoped for. And I was very, very lucky. I went to Texas. I think that was when we were writing the moon book. So it was published at the end of 2018 for the 50th anniversary, of course, as we're writing it in 2017, 2018. And I went to Texas to give another lecture, and there was a lunar eclipse. And I was with people on the roof of a building, clear night, and a fantastic telescope. And that was just the most visceral experience. So I really felt like, there you are. And, I, like most other humans, I would say all other humans before me, and who are now on this planet, we have that connection with the moon, spiritual connection, but also a very sort of, physical connection, because it is so close to us. And we did go. We can reach it, we can walk on it. And what a thought that is, to walk on another world. And I felt all of that coming together in that moment. And I could take a picture with my mobile phone, holding it onto the telescope. It was wonderful, the viewfinder. It was great.
I actually find also that I'm not bad at taking pictures on my mobile phone through telescopes. You can get special adapters to make it easier, but I do find actually younger people who are so familiar with phone photography, they just do it click. And I think, how do you do that? How do you line it up so fast?
Yeah, but that's great, isn't it? Because a lot of people say, oh my God, once we have the telescope, it's no longer that sort of wonderful, symbol of whatever. It was still a symbol of more than just science, of the human condition and where we fit in. So the Romantics didn't care that we had telescopes. They still wrote these, poems about love and
Well, I agree, and actually,
and then what Boch said, my God, now that we're on it, now that we've been on it, what now? What next? And it doesn't matter. It still fascinates us, and it's great that the young people now can just hold up.
Well, yeah, and you introduced me to the description of the Romantic period as the lunar period in German art and so on, and particularly, Caspar David Friedrich's stuff, like two men looking at the moon and those images.
Yeah. And as you know, as you have confirmed, a lot of those Romantic paintings where you see the moon, a lot of them are actually accurate. And earlier ones, and also later ones, there are expressionist paintings where you might think, oh my God, that's just, splotches of paint, done for effect, and there might be a star or moon. But a lot of them are that combination of human expression and emotion, but also observational. So we know that, Vincent van Gogh's Starry Night is actually a pretty accurate depiction of what he saw. Not visually accurate, but in terms of where things are.
And also that was a reflection of the time when there was less light pollution, right? So you had no matter where you were, cities may be lit with a few braziers, but not much. So even from our large cities, people would have had that kind of view. But of an unfettered night sky. Although obviously the contradiction here is that the brighter the moon is in the sky, the fewer stars you see. So it's a trade-off, but you have to look on the plus side.
There are also impossible paintings, of course, where suddenly there's clouds behind the moon and all that. All that happens too. We see that a lot in sort of manipulated early postcards, photographs that have been sort of touched up with suddenly. But also, we're going sort of into the visual arts here, but if we stick with writing and that idea of wanting to imagine ourselves or a world like ourselves, with craters, with mountains, with, and we name it like our world, of course. And once we get to science fiction, the real science fiction, there's Jules Verne and H.G. Wells and everything after. Of course, in a way, we got, we create what we sort of, wish not wish for. Yes, we place narratives on the moon. So we get there, in these science fiction novels from the late 19th century onwards. So yes, we get there and we explain how we get there. That's the science bit in the fiction. But then, of course, what happens there? It's all about conflict. It's about fighting over whatever is on the moon or not on the moon, or colonizing the moon, and so feuding armies. What's new?
Indeed.
It really is a reflection of ourselves.
Indeed. No, I couldn't agree more. And absolutely projecting those human conflicts on there. I can see from the chat actually that I think Agapios is now looking at Jupiter. So let's go rather further out into the solar system than the moon and go, I think, several 100 million kilometers to Jupiter.
Bye-bye.
Bye. See you later, Alexandra.
Yeah.
Agapios.
Well, have I got a treat for you? Yeah,
Excellent.
have I got a treat for you? So I just pointed the telescope at Jupiter, and well, lo and behold, there's a moon shadow transit happening, and I'm just gonna share my screen now. Hope you can see that.
We can actually really
Okay.
well. I mean, that's such a nice segue, isn't it? That we've gone from talking about the moon and the Earth to not forgetting that there are well, I'm trying to think actually, 250, maybe more moons in the solar and other planets around the solar
Too
system.
many.
So do you know which moon this is?
Yeah, actually, we're looking at a shadow transit of Io. So we're looking at the shadow of the moon Io cast on the cloud tops on Jupiter. And you can also see the moon Ganymede here. You would be mistaken in thinking that this is the moon that's casting the shadow on the planet, but it's not. Io is actually somewhere around here, and we're just going to get. It's just going to pop out of the disk of Jupiter in a few minutes, and that's the moon that's casting the shadow there. But Ganymede, as it's going to come closer, a couple hours from now, we'll really be able to see even some surface features on the moon Ganymede, which you can do with a fairly modest telescope. You don't need a huge telescope to see that. Of course, it helps if you have one, because it's assuming it's well calibrated and everything, you can really pick out some really interesting details. And to be honest, I did capture some data before, just before I came on Jupiter. And we could, if we have time, just show a really quick sort of astrophotography magic into turning the live view into a processed image. If time allows, just let me know.
Sure. No, well, I think, yeah. How long would it take, do you think, roughly?
I think just a few minutes. Just
Well, I mean,
quickly. Yep.
you can give it a go. I mean, if you think that we could, can we carry on seeing what you're showing through the telescope at the same time, or do we need to switch away from that?
Yeah, I think we can do that.
Okay, well, if we can still see, honestly, if you can do that in the background, then I think that would be a lot of fun. Actually, I can see there's a question
Of
as well
course.
we can talk about.
So I'm keeping the live view on, and in the background, I'm just going to quickly do some processing to see what we can tease out on Jupiter.
So while you're doing that, somebody's saying, Matthew Henson, would you recommend for the Europa Clipper to go to the Jupiter system first and then JUICE? So for context, Europa Clipper is he says, checking, these are different missions that are planned. Europa Clipper is a NASA mission that will go to one of the moons, Europa, which is not on the screen. What we're seeing is Ganymede, which is the biggest moon in the solar system, as I recall. It's significantly larger than our own. And it's one of the 4 moons that were discovered, or at least discovered to be moons, by Galileo back in the early 17th century. And he wasn't the first person to see them. That was, if I recall correctly, a Jesuit monk called Simon Marius. But he identified them. Finding that they were going around Jupiter was earth-shattering, because it overturned the idea that everything went around the Earth. And so it gave weight to the argument that the sun was at the more or less the center of the solar system rather than the Earth. And he got into trouble with the Catholic Church in the 17th century for that. But by the way, the Catholic Church now has a really great observatory in the Vatican and so on, or run by the Vatican. So things move on. But there's interest in the 4 biggest moons: Io, which we can see the shadow of, Europa, Ganymede, and Callisto, because they're big enough to be worlds in their own right. And Io is very volcanic, has all these eruptions on it. Europa, and actually the outer 2, Ganymede and Callisto, there's an enormous amount of interest in them because we think they've got oceans under their surface. Now, in Europa, it's most obvious. It's about the size of our moon, but it's got an ice crust. And we see all these dark markings on it, but it's basically ice. And the idea with that one is that Jupiter's gravity stretches it, like the tides do the seas on the Earth, stretches it, heats up the interior, that melts the ice underneath, and it makes a big ocean. And so the Europa Clipper is a mission to go and study that closer, to go into orbit, or to go close to Europa, actually going around Jupiter in various flybys, and to look at it up close. So that will get there, I am checking, I think around 2030 or so. Takes a while to get there. It's already on its way. And so, really great thing to do. And then the JUICE mission is the Jupiter Icy Moons Explorer, which is the European Space Agency. And that's going to go to Ganymede a lot, looking again for things like a subsurface ocean, and I believe some of the other moons as well. The reason for the wanting to go there is partly, it's not, who knows what the odds are, but these are places there might just be life, because the subsurface ocean, on Earth, the dark as the ocean depths are, we do find life around these volcanic outlets at the bottom. So, that's why there's enormous regions of this. So when you're looking at this picture now, looking at that shadow, looking at Ganymede just off to the left there, just remember you're looking at worlds that are big enough to have actually huge oceans under the surface. So back to Agapios, maybe if you carry on telling us what you're seeing there. That's looking really good there, that image. Absolutely fantastic.
Yeah, and of course it has to do with the fact that Jupiter is actually much, much higher in the sky compared to where the moon was before. And I'm just finishing up processing some data that I got just before we came on showing Jupiter live. So I am going to take the live view away from you for a bit to show you what the result is of the astrophotography magic that I talked about before. So what I did was I recorded a few thousand individual pictures of Jupiter, which were recorded in a video file, and I selected the best of those, combined them together in a process called stacking, and now I'm going to take that stacked image and do some sharpening, and this is really going to clean up the image and show us fine details on Jupiter. I hope you can see the unprocessed image now on the screen,
which looks amazing, by the way. I have to say, even the unprocessed image looks fantastic.
Well, just wait. So I'm just going to start teasing the detail out now, and you can immediately see how this transforms. And as if showing a moon shadow transit on Jupiter wasn't enough, we are actually looking straight down at the newest cloud outbreak that's been happening on Jupiter. So Jupiter is a very dynamic planet, is the most dynamic planet in the solar system, completely covered in clouds, and there's violent processes happening on Jupiter all the time. And one of those we can see just here in this region. This is the northern tropical zone on Jupiter, and you can see sort of this darkened area here that looks rugged and distorted following these bright patches. This is the result of a new atmospheric event that's been happening on Jupiter over the last few, I think, just a couple of weeks since the first time that we noticed that.
Agapios, I was going to say, for context for people watching, to give you a sense of scale here, you can fit 11 Earths across the face of Jupiter, and you can fit 1,300 Earths inside. It's a gas giant, and it really is a giant. And there's no solid surface either. If you stood on it, you wouldn't stand on it, you just sink down until you're crushed. And actually, we did do that with a space probe back in 1995. The Galileo space probe did just that.
Exactly.
There's also a question like, where is the red spot? And I don't think we're looking at the right hemisphere. I imagine it's around the other side. Is that right?
No, it's actually on the other side. We will be able to see it tomorrow night. But we can actually pick out Io right here. So this little tiny bright spot is the volcanic moon Io that is casting this shadow across the cloud tops on Jupiter. And for anybody with a fairly large telescope, it's really interesting if you can observe how these dark silhouettes move across the cloud bands and how they differentiate. The solar system in general is just so dynamic. You never know what you're gonna observe when you point your telescope at a solar system object, whether it's the moon. Yeah.
And also, the other thing to take on board here, which I agree with you, is phenomenal. The dynamism, the features here are amazing. What you're doing here is producing images with not a small telescope, but a relatively moderate one, that were better than anything we saw published by professional observatories 50 years ago. I remember all those textbooks in the 1970s, kind of shows how old I am. But the sort of imagery you're showing was better than they could do because computer systems advanced so much. And the difference is going from trying to do this with photography to doing this with electronic detectors, the sort of revolution, the kind of cameras, you know, that we take for granted, although rather smaller with our phones, and the way you can process those.
Exactly. And you can just see Io now coming out of the front of Jupiter, and it really starts to give that three-dimensional effect. And I was saying before that I honestly think the solar system is just so incredibly dynamic. And even though it's only it's somewhat limited in terms of the number of celestial targets that you can observe. It's just those 5 planets and the moon and the sun and maybe the occasional comet. The fact that it's just so dynamic and ever changing really makes up for that. And it's just so incredible the fact that such a dynamic field is accessible to somebody with modest means. Any tiny or small telescope will show you these basic features that we've been talking about tonight.
Agapios, do you know how much? I know that it used to be said a long time ago that, you know, amateur astronomers could, with this kind, well, maybe, I don't know, maybe that was before they had access to this kind of equipment, could make a contribution to the science. Do you know to what extent amateurs are still collaborating with professionals on planetary science in particular? Are they still doing
Actually, yes, I do. Given the fact that today there's been such an incredible revolution in terms of image quality when it comes to sensors, and just how much they've evolved over the past few years. I know there's people taking part in professional amateur collaboration projects using telescopes as small as 4 or 6 inch in diameter, which are very, very modest. So the fact that somebody today can have access to equipment that can contribute to science and be so accessible and affordable, it's just incredible to me.
Jim Hendrickson is saying via the chat, you can see Io coming out transit now. Absolutely, you can see this bulge on the right where it's just emerging from moving off the disk of Jupiter.
Exactly, exactly. And just to give some to give some reference, the live feed that we're looking at now is actually 125 frames per second. So assuming all of those make it through the internet chain coming to you and being transmitted over on the YouTube, viewers are seeing multiple individual frames per second shooting across their eyes. And you can still see the shimmering of the atmosphere that we talked about before. And here's where the astrophotography magic that we were talking about before really comes into play, because we can use incredibly powerful software that's free, completely free, to harness information, data, process it, and produce high quality and high resolution images with very little effort. And those are scientifically useful.
That's and that's an absolutely amazing contribution. I mean, I think, I don't know, again, I don't know how scientifically useful they are, but I'm always impressed by the fact I seem to know more and more people who've invested in this C-star electronic imagery that just does, it's not that good for the solar system actually, but it takes pictures of other things in the sky. And yeah, I mean, it's not that big a telescope, but you see extraordinary pictures that they've just set up by leaving this thing running for an hour. And C-stars are really quite incredible.
Yeah, I can tell you what, I have been an active astronomer for over 20 years. And the things I've seen over these 20 years is just incredible. And especially just the past 5 years, just how much things have changed. Following COVID, there was just such a boom in interest in astronomy and astrophotography. Just so many people became interested in it. And this has led to such demand, and so many high quality offerings have come out. And people really do today. I envy them a lot, because somebody can have access to equipment that at least back when I was starting out, it was science fiction, something like a sea star, much less something like an observatory telescope like this.
Yeah, absolutely incredible. No, and I think, the fact that, okay, they're not cheap, but they're, they're several £100, but Just the
Well,
fact.
if I can just say this, and this is what I talk about here locally on the island when people ask me how to get started in astronomy and stargazing. I don't like to say spend, I'm going to say invest. So if you would invest what you would on an average smartphone, not a
Yes,
high
that's
end,
true.
not a low end, just an average smartphone, and turn that into a telescope, you're going to have an instrument that you're going to keep for the rest of you. Have it, your grandkids will have it, and it will serve you so well to show you so many things and discover so many things in the night sky. That's just for me. It's incredible how not everybody has one. It should be the case. Every home should have a telescope.
Well, no, well, that I would absolutely agree with, and I think also I always say to people for accessibility, even just buy a pair of binoculars if you don't have one, because you can try them out very easily. They're super accessible for getting stuff into your eyes, fundamentally getting light into your eyes. You will see details on the moon. You can you see things like the moon's a Jupiter. You don't see any detail on the planet, but you see the moon's a Jupiter, and you can use them for other things. So yeah, no, I would agree with you.
And if I could just say another small thing, get involved, seek out your local astronomical societies, go to your local astronomy museums or observatories. If you have access to facilities like these, which are run by people who are passionate about this, and really reach out to them, because I know, speaking for myself, I'm just so eager to share this wonderful gift that we have here in Cyprus, this incredible astronomical setting that we have here. Clear skies all the time, a beautiful mountaintop observatory, and I mean, think about it. It's the 3rd of February. We're in deep winter, and I'm just sitting here casually on the top of a mountain, a beautiful clear sky. I'm not cold. I'm perfectly fine. Okay, I have a beanie on, but that's it.
Yeah, but well, that's also Agapios, I think to follow up on what you're saying, for people, I mean, I can speak for the UK context, but I'm sure it applies in a lot of places. Another great resource is if you go to these local astronomy societies, and there are hundreds in the UK alone. So, and very many of those will be full of people who have some of this equipment we're talking about, who they will run observing events. They're generally full of people who are very enthusiastic about letting you look through telescopes, actually enjoying the view. There's got a social experience with it as well. So, do get in touch with those. I mean, I can think down the road from me, the Hurstman-Sue site, the Observatory Science Centre, absolutely fantastic. Saturday night when it was clear, I was there looking through these historic, quite large telescopes at different objects, and just an extraordinary atmosphere, absolutely incredible atmosphere. So I thoroughly recommend that if you're near anything like that, or you can travel to something like that, do exactly what Agapios is saying. If you don't, place like the UK, yes, there's a risk with the weather. Even if you don't see something in the sky, you have the experience of being in a dome with a telescope and having that expertise, and that it's just absolutely evocative. So I can
And
see
remember, we're only a few hour flight away, and there's 2
well,
airports.
there is that, exactly. and if if people are going to Cyprus on a holiday anyway, for example, I always love the Mediterranean skies. Actually, I have to say, going down to southern Greece, which I've done, and Crete and so on, it's just extraordinary being able to see the Milky Way higher.
Yeah.
The center of the Milky Way, the center of the galaxy, is so much higher in the summer months. It's just
And this is something that I try to communicate to my local audience here, is that for the locals, the fact that we have the skies that we have, as close as we have them. I mean, for me, coming up here, it's an hour and a half drive, which for Cypriot standard is a long drive. But for the UK, I'm assuming it's something like your morning commute, more or less.
Depends. It depends where you
Yeah.
are. Yeah, mine is slightly worse actually, but yeah, exactly so. So, I think there's more requests now to look at Mars. So,
Yep, gonna do that now.
Back. So, we'll leave you to do that for a few minutes. I'm going to, I think before I bring Alexandra, just give her a pause for breath. I'm going to share my screen because there's one other thing I wanted to show people if I've got my PowerPoint running. Here we go. One more slide. Okay, this, right, hopefully you can all see that. It's an animated GIF. So I hope, apart from the streak, you can see a little dot in the center. And this is a series of frames showing the movement of an asteroid toward 2024. I think I'm right in saying it's YT14. I don't have the details on my screen, but it is maybe up to 90 meters across. That's not very big. That's sort of football field sized, and you can see that it's moving in front of background stars and probably a few galaxies actually as well, and looks pretty faint. And it was discovered by this Atlas robotic observatory that's based down in Chile, I believe. And there are a number of these now whose job it is to find asteroids, to find objects. And the reason we want to do that is because we worry that some of them might one day hit the Earth. In fact, you know, that's if you run the clock forward enough, that's inevitable. It's happened many times in the past. But I don't lose that much sleep over it. Now, this one's got a lot of interest because, as actually happens several times a year, so to give it context, it's calculated that there is a 1.4% chance of it hitting the Earth in 2032, so in about 7 years' time. Now, the reason I'm not worrying about it too much is because there's still a 98.6% chance it won't, and also because generally what happens when astronomers measure their position over a longer period of time is that they realize they're actually going to miss the Earth, and that happens with, you know, all of them so far. But the other interesting thing about this one, if you've heard about it, is it's of a size that if we wanted to, we could nudge it, we could direct it out of the way, because there was a mission called DART a couple of years ago, and that was NASA wanted to try and deflect an asteroid similar size, and it worked pretty well, sending something with a mass of about 600 kilograms into that, impacted it, little eruption material came off, nudged the asteroid slightly, you know, so the technique works. So I'm including it because there's a lot of coverage of it, I think, in the last day or two in the news about this. Some of the, you know, the BBC were talking to me earlier about it. So just, I thought it would be a nice thing to mention. I don't lose too much sleep over this as a risk. I just think it's a really good argument. Well, there are many arguments actually for doing astronomy, but this is a very practical one. If you want to see things like this coming, then continue to support astronomers and the kind of work they do so they can alert us to these events. Alexandra, I'm going to stop this now. You're there again, I think, aren't you? So how are you doing out there? Have you seen Mars through a telescope, Alexandra? Maybe we should set this up sometime.
No, I haven't. So, Robert, when I'm back in Sussex, which will be tomorrow, please get your telescope out
I
and
will.
invite me
I
up
will.
for,
The skies are clear.
you know,
We're on it.
yeah. So it is a great privilege, sort of looking at something that fascinates me on a sort of metaphysical level, and from an art point of view, visual arts and but also poetry and the the written word. It is great having I'm going to use the word scientist carefully, because when we look back to 200-300 years, that sort of division between the arts and the sciences wasn't there to the same degree. So people like Turner and Constable did go to those lectures that were, being given in central London, and they were fascinated with what was going on, in the world of the sciences, and that filtered into art. So there is that, they weren't so worried about what is what, and I guess that's what we tried to do with the book, wasn't it? To sort of give these
exactly. Well, I think, it was what I loved was that actually Banud, who's online, is the local, has just said I'm in as well for stargazing. There you go. So he's got a good telescope. He knows what he's doing. PhD student, originally from Iran. He's a brilliant speaker, by the way. Great guy to have. But yeah, I absolutely agree with you. And I think actually what I think is really interesting is that what is an opportunity to kind of reflect on those things and those influences, because, I mean, credit to you, it was your idea, this book originally, and then I just thought, oh yeah, why not, I'll just do it and work with you on it. So that was a great experience. But and as well as our impromptu tour, which we got in just before COVID as well. So
it was amazing. We were sort of on the moon tour, and and we got invitations from sort of your side of things and from my side. It was really interesting how skeptical people were about certain things, and what questions we got when we gave a our sort of joint lecture to say an art group, whereas go into astronomy groups is really fascinating.
And-
But
Right.
so and I hope we don't have to sort of labor that point too much. But for example, if you look at a painting painted in 1609, I now know that whatever if that painting shows a night sky, there is the possibility, anything that comes up, there is a possibility that the artists would have known about telescopes, or would have even had one, or would have had a greater sense of what it means to observe the sky, and from an art history and from a general cultural point of view, you could bring in, well, how does that then get tied up with the symbolism of the moon? If it is, a religious painting, so what happens then? So how is the Virgin Mary depicted, 50 years after the invention of the telescope? What kind of moon is she standing on then? Can we see the craters? And we had this great example of the early 15th century, Jan van Eyck, which is quite possibly the first painting of a moon in the daytime. Of course, it was a crucifixion scene, as in a very small panel of an altarpiece, and it's in the Met. And so Google it, people. Jan van Eyck, altarpiece in the Metropolitan Museum of Art, New York. So you see in one of you see the crucifixion, and there is a moon. And of course, no telescopes yet, but what you see in that painted moon, that painted moon, shows you pretty much what was visible to the naked eye. So
And
it's
do you
really,
remember
really, yeah, absolutely, no shadow about it. It's a religious painting. It was made for a religious context to be placed in a place of worship, or and then there is an accurately painted moon. Why?
Yeah, exactly. No, and I remember also going out down the bottom of my street. This is when I lived in Bristol, and I saw it at the same phase, taking a picture with my smartphone. And of course, actually, you don't get an enormous amount of detail with a smartphone. It's a small lens, and it looked basically exactly the same. So, you could see, you thought, okay, at that phase, he'd captured it very, very accurately. I was going to make one other thing as well, one other point, which I'd refer people to this year and the year before. We've been involved, this is the Royal Astronomical Society, with something called the Major Lunar Standstill. And this is a time every 18, 19 years or so when the moon reaches extreme northerly and southerly points in its orbit. And there's an investigation going on at places like Stonehenge, and also in counterparts like Chimney Rock in the US, with the First Native monuments there or features, to see whether the alignment of stones captures that. So
Interesting.
Yeah, this
Yeah.
resonates back thousands of years, even at least in the kind of artifacts that were being built. And there's even a suggestion, for example, that some of the Lascaux cave paintings, which go back 40,000 years, might depict.
Yes, really old, possibly the first depiction of the moon as a sort of moving thing, as something that sort of can be tracked, or something that gives us a sense of time, of a cyclical pattern. It may just be they look more, and you see them on bones as well, so not just on the cave walls, but also it's scratched onto bones, either just charting the lunar cycle,
And
a timekeeper. Yeah.
And also, the other more modern one, well, relatively more modern, even 1,300 years ago and going forward now, in the Islamic calendar, it's really important seeing the crescent moon at the start of each month. Just a beautiful sight as well, actually. I can see why it was so evocative, and why that ended up in Islamic art in such a big way. I believe now from the chat that Agapios is ready to show us Mars. So coming a bit closer to the Earth, but still a long way away, tens of millions of kilometers away. It's hard to get to Mars, I should say, if you're wondering why we haven't done it. It's 6 months there, a year on the surface, 6 months back. Lots of things, we'll go someday. But in the meantime, let's have a look at what it looks like from the Earth.
Well, I can tell you one thing. I think we picked the best night.
Oh, wonderful.
Because I'm looking at a beautiful view of Mars here in the telescope. And we're actually looking straight down to the area where Mount Olympus is on Mars. So we should be able to pick that out later on. I'm also processing in the background.
Brilliant.
Trying to see if we can pull out the volcano. You will immediately notice that that Mars is just so much more tiny compared to Jupiter that we were observing before. Still, there are some interesting features that we can make out. It's a notoriously difficult target for small telescopes. It's just tiny, no matter what you do, no matter what magnification you use, it still looks tiny. But with a larger telescope and some astrophotography, you can really make out some interesting details. But we can see the northern pole on Mars. We can see the northern polar ice cap. It's just coming into view there. The atmosphere has turned bad a little bit. There's a lot more shimmering now compared to before, and I can sense that it's actually turning cooler. But we can still see some interesting details.
While you're talking, Agapios,
Yeah.
someone's asked about the geysers on the polar ice caps on Mars are perfect. What do you see from Mars Express? Mars Express is a European mission that's been there since what, 2003, I think, and that shows close-ups of this. One thing I would emphasize is that, to reinforce what Agapios was saying, is that the details on Mars are so tough. And if you ever wonder about those observers who imagine they saw canals, well, if you look at Mars through a telescope, it's fleeting. It's only good every couple of years. It's only really good every, how long is it between the really good oppositions? Every
About
15
15.
years? 15 years, 15, 17 years, exactly. So those observers, they were looking for periods of time of a few weeks, at most every 2 years, and often a decade and a half apart. So it's amazing they managed to do what they could to map it as well as they did. And I'm very forgiving of the fact that people looked at that and on the edges, they imagined these straight lines and started to think about civilizations on Mars and canals and all the rest of it.
Yeah, I was actually fortunate enough to visit the Brera Observatory in Milan, and I got to see Schiaparelli's telescope. And it was right around the Martian opposition of 2018. And I remember I was imaging maybe the night before I went to the museum. I was at home imaging Mars, and the next day I got to find myself in Schiaparelli's observatory, and I just imagined what he would think if he could see the kinds of images that we're getting these days with these telescopes and these techniques.
Oh, I mean, it's beyond recognition, isn't it? I mean, just the capabilities of what you can do processing images from relatively small telescopes. And yeah, I mean, picking out features that we only before associated with space probes. Just
Okay. Ready to do the grand reveal? Let's see if we can get
go for it.
Olympus Mons to show up on screen. So there's the unprocessed image, and I'm just gonna do some
It's
sharpening.
still really good. But
yeah.
phenomenal. For
Yeah.
everybody watching as well, remember Mars is only half the size of the Earth. It's quite a small planet, and it's a long way off. It's trying to remember the numbers, but 70 times as far away from the moon at closest, a really long way off. So, so to be able to see this level of detail is extraordinary.
So it should be right here. There is a slight shading there. Let me try and zoom in a little bit. So it should be this slightly fuzzy feature right here is Mount Olympus on Mars, the largest volcano in the solar system, about the same size as France, if I remember correctly.
Yes, I think you're right, and it's 3 times the height of Mount Everest, as if I recall.
Yeah, exactly. So. And again, Mars is also a really dynamic planet because we get a lot of dust storms on Mars. And if you remember, during the last National Astronomy Week, we were able to track one of those storms while it was happening during the same nights as the National Astronomy Week, and we got to see its progression across the face of Mars in the course of a week, and it was just an incredible phenomenon to follow.
And Mars has a very thin atmosphere, right? But it's lifting up this very fine dust and that must also, I suppose, telescopic observers, particularly the late 19th century, when they built these large refracting lens telescopes, they were able to see those changes. And there was speculation like, were they seeing changing vegetation changing with the seasons, for example? Because right up until after the Second World War, there was still serious speculation about there being not just maybe very primitive life that we might imagine on the surface of Mars, but actually something more complicated. So there might be, plant life or at the very least.
I'm just going to check in with Agapios here. Was he talking about the dust storm we had in 2020 on Mars that we saw at the
Yeah, that's right. Yeah.
and at the National Astronomy Week Encounter Mars in 2020, which I was the chair of, and that was really exciting to see the dust storm on Mars live when we were doing live streams then. That was amazing. And you can see those on our RAS YouTube channel or on NEW's YouTube channel as well.
Yeah. And to think that what we're looking at the screen now, this distant world, is actually our next destination as a species, and that someday we may be doing this while there's people on the other side, and we could possibly in some far off date in the future do a National Astronomy Week where we have astronauts on Mars looking back at us. Who knows?
Sending back pictures of the Earth.
Yeah.
There are wonderful, I mean, if you go to the various space probes, robot space probes trundling around the surface of Mars, the rovers, many of those take pictures of the sky, and sometimes they do even include the Earth in the sky and the Earth and Moon. Only as dots, but nonetheless, it's nice to see.
I'm just working on the telescope now, just trying to improve the focus a little bit because I think conditions are becoming worse.
Well,
but it's still a clear sky.
A lot better than here. So exactly, you have a clear sky. Somebody's asking about going back to look at the moon. I'm guessing it's a bit too low now where you are. Is that fair?
Sadly, yes. It's actually behind the mountaintops. It was actually a beautiful setting before. I could see it set behind the mountaintops, but it's out of reach for tonight.
Another time. And if you are, depending on where you are in the world, if you're watching tomorrow and over the nights ahead, the moon is going to be easier to spot. Well, at least it's going to be visible through more of the night. So if you have a clear sky, and as we've been saying, if you get even a pair of binoculars, you can get a great view. It's really phenomenal.
I actually wanted to point out that there's another really interesting feature that we can see tonight right here. The Mariner Valley, Vallis Marineris, which is also known as Grand Canyon on Mars. It's a fascinating feature on the surface of the planet. Really deep and extended canyons and really dramatic landscapes. It's one of the most well-known features on Mars and the solar system in general.
That's one of the, I think, is again, I recall, on a big scale, much smaller planet, but I think is what, 3 times the size, 5 times the length
much bigger. Yes, it is much bigger than the equivalent on Earth, the Grand Canyon.
Yeah. So and formed through a very different process, but nonetheless, they're really extraordinary. I mean, I particularly like the other thing that I've been looking at a little bit here with a small telescope because I like looking at Mars, and the view is not actually that different to the blurry one you're showing there. It settles a bit sometimes. But when we did the previous National Astronomy Week, which Lucinda is driving this in the background, chaired then, as she said, and we had to do it entirely online because it was the height of the COVID pandemic, the worst year of it. We were observing Mars when it was much closer to the Earth. And yet for us in the UK, it was low down, so it was a poor target. Whereas this year, although it's much further away, it's actually, I found I'm getting a better view. It's because
exactly it's the Martian paradox.
Yes, for the northern hemisphere anyway. If you live in Australia, you get a much better view when it's close to the Earth.
For us here, way back in 2003, when we had the closest approach of Mars in the modern era. It was only, I think, if I remember correctly, something like 25 degrees, and we are at latitude north 34, so we're fairly down south. But the 2020 approach, Mars wasn't as close to the Earth as it was back in 2003. It was just maybe an arcsecond and a half smaller. But because we've had such a huge leap in technology and in optics and you know the high quality images that people can put out. The 2020 apparition, I think, was the most productive for most astronomers throughout the world, because for the northern hemisphere it was something like 60 degrees in altitude, at least for me, something like 60 degrees, maybe 40, 45 for you. But it was just close enough and big enough and high enough and at the right season, September, October, somewhere there, which was just beautiful. We had an extended period of time observing Mars and putting out some really high quality images. I thoroughly enjoyed that apparition.
There you go. Various comments coming. Emma Pasculi says, amazing. I agree. I was just thinking, I saw it in 2003, and this is, I'll never do this again. I'll never be like this again. But at the time I worked in Greenwich, I got to use the antique 28-inch, so it's that 70 centimeter refractor. It's a large lens telescope. And there was it was terribly set up for it. We had to, my colleague Robin Catchpole, who was there at the time, we had to open up the dome, and we just had a slot where it would drop into this notch between two railings, and then Mars was there, and the dome was left open. It was a beautiful, beautiful spell of weather over the summer, and we let it cool down, and we had this extraordinary view, but only fleeting. And that was the one time I'd looked and I thought to myself, you know what, I understand what all these astronomers like Percival Lowell and so on were talking about, and Schiaparelli, that they have these beautiful views, but only for a few days. And then presumably they went away and they waited, and they did this maybe 3 times in their life, and that was it. That was it.
Yeah. But of course, a case can be made for those astronomers. They were just so incredibly patient, spending hours and hours and hours at the eyepiece of a telescope, observing, just waiting for the right moment when the atmosphere would be stable enough to glimpse the finest possible detail. And this is again something that I highly recommend for beginner stargazers to really get used to being patient, because when you get the right conditions, the view of the planets through a home telescope under the right conditions is really unforgettable, and you will be hooked, immediately hooked.
I absolutely agree. And I think particularly, you know, Mars is a tough target, but, you know, Jupiter, as we've seen, is great. And also, at different times, Saturn right now, if you're wondering why we didn't show it, partly it's actually pretty low over in the western sky, but also the rings are almost edge on, and I think it's what they're actually edge on to the Earth in a few weeks' time. So
exactly, yes.
Yeah, but and then they'll open up.
Saturn is actually the most challenging to observe, because it doesn't really have high contrast features other than the rings. So when the rings are in the position that they are now, almost entirely edge on, the planet is so dim that it becomes immediately much more difficult to observe and tease out those fine details of the cloud bands. But when the rings are so close edge on, we do get a lot of shadow transits of Saturn's moons, which was the case this past few months. We were able to observe from the observatory here as well. We were able to observe Titan's shadow cast onto Saturn on multiple occasions. That was a rare and spectacular event to see. Another nod to just how dynamic and wonderful and unpredictable the solar system can be.
No, I quite agree. And I think, you know, again, it's a reminder that Saturn and Jupiter, and we can't show you these, but Mars only has 2 tiny moons, but Saturn and Jupiter have, I'm not even sure of the number in each case, but getting on towards 100 in each case. They've got a huge number. Most of them are tiny, but they are like miniature solar systems in their own right. And there's a tremendous interest in the moons of Saturn as well. Titan, big moon, actually has a thick atmosphere, thick nitrogen atmosphere. It rains liquid methane. And then there's Enceladus, where jets of water are coming out into space. So these are top targets for future space missions. People really want to find out what's going on. You might ask why we want to do this. Well, the answer is it's part of the quest for life. It's trying to understand if there are habitats elsewhere in the universe, or even in the solar system, where there's life, or where life might have been able to emerge. And it tells us, you know, therefore it might also tell us about the origins of life on Earth as well. in a couple of minutes, I think I'll switch back to a quick mention of the rest of the National Astronomy Week events, because this is an event for that. Any final thoughts, Agapios, in the last couple of minutes?
I'm just really enjoying the night, being able to share the view with you over the internet and to everybody watching. I highly recommend you consider stargazing as your hobby, and maybe even, why not? Maybe even a scientific endeavor. There's just so many fields active, so much frontier science being done, and so many notable scientists started just by being stargazers. So to any young ones watching, please do become inspired. And as always, feel free to reach out for any questions or comments on telescopes or observing or Cyprus. Why not? Or always happy to chat with people on those.
I couldn't agree more, and I think you're demonstrating that tonight, and a really inspiring set of materials and description of what we're seeing as well. Absolutely astonishing. Alexandra, do you want to come in with any final thoughts? I've got a couple I'll add in at the very end, and then we'll.
Well, I'd like to break down these barriers, these perceived, barriers between science and the arts and writing. And when you look at the moon or Jupiter or Mars or just the stars, just bear in mind, it really is quite helpful to think about what did, humans before us know, what tools did they have, what did they know about those objects in the sky, and it'll help you understand why you react in a certain way. So yeah, that's what I would say. And write some poetry about the moon.
Yeah, write some poetry, by all means send it to us, or tag us
or
on.
read poetry about the moon. No, it helps. Yeah. It helps with the bigger picture.
I couldn't agree more. I was also thinking, if people take pictures and that kind of thing, tag us on Instagram, on in Facebook and Blue Sky and so on, and we'll try and we'll look for those, maybe like them, amplify them a little bit if they're good. We like doing that as well. 4 minutes left. I'm going to mention a couple of things. One is a plug which I ought to place as well for our podcast that we do every month, actually a couple of times a month now. It's hugely popular, but if you haven't come across it, please check it out, the Supermassive Podcast. We have a brilliant set of guests, and we cover all kinds of topics in astronomy, and we give a description of the night sky each month as well. So if you just look up Supermassive on whatever browser or platform you use, then you'll find it there. So do that. And then the final thing I'll mention is, of course, this is, we're only 3 days into National Astronomy Week. There's 6 more days to go for this in the UK. You can see the QR code on the screen now. And there are various events going on. I mentioned at the start. I don't know if we can get the map up, but there is a map of the UK showing the distribution. There you go. Look at that. 250 events, I think, there are across the UK. There is going to be something near you. If you go to that map, click on the dots, you'll find what there is. There's also a list, and they're spread across that. And there's a huge range of things. It's looking through telescopes, which is, to my mind, the best thing you should be doing during National Astronomy Week. But this is the UK. We might not have the weather you want. However, there are also talks, other live stream events in observatories, science centers, and so on. So we really want you to go and look at those. And these are, most of them, I don't know about, not absolutely all of them, because some of them have a charge, but most of these are free as well. So you can just go along and take part. In my own town in Lewis, 2 nights time, guests can come to us for £4, for example, to hear a talk by my brilliant colleague Kate Land on the paradox in cosmology. I'm only mentioning that because it's one I know about. No disrespect to the others. There's just so many, it's impossible to remember them all. And you can get these resources as well. You can download things for children, but also, actually, there you go. Story 16 minutes. Sorry, I'm reading a video of a traditional tale told by storyteller Astor Daniel. And a whole host of other things as well. We've got various videos, things like one that was done by the late Heather Cooper, talking about the changing face of Mars, for example, and information on what and when you can observe things too. So do check all that out. The aim of this is to try to do it for people at many different levels, many different ages and backgrounds. And so we're trying to hopefully have something that will appeal to everybody in there. There we go, and there's the video for the promotional video from Chris Lintott there. That was going to be my screen grab for the slide I had about it, actually. So with it, yeah, neatly done by my colleague Sam, actually capturing him smiling mid-expression there. And you can see all that for yourself. We've got 1 minute left. If there are any questions on there, I can take them if someone jumps in quickly and give a 30-second answer. Otherwise, we'll bring it to a close for 9 o'clock exactly. Agapios, I need to give huge thanks to you. I know you said it's an hour and a half's journey, but so much appreciate you doing this. And I know it's something I can tell it's something you absolutely love doing, but that's not the point. We really appreciate you sharing that with us, and the amazing imagery, amazing job you've done tonight.
Thank you so much for the inclusion,
anyway, Alexandra. But yeah, thank you. We currently live next door to each other for a few more days. So.
Yeah, thank you so much for the inclusion. Very happy to be a part of this and show the wonderful Troodos Observatory in the night skies here in Cyprus. I hope you enjoyed it. And as I said before, for anybody watching who has any questions or comments, feel free to send them in. More than happy to answer questions and provide some guidance for people who want to take up stargazing and discover the night sky. And keep looking up.
Couldn't agree more. Thank you. I think that's a perfect place. It's 9
yes,
o'clock.
wonderful.
To bring it
wonderful
to an
way
end.
to finish. Thank you all, especially Robert, for inviting me again. Thank you.
A pleasure, and thank you. And I think happy stargazing seems appropriate. I sign off with that more and more these days. So bye, everyone.
Bye.